these are some topics I showed in the Mathcad file. So this is the data exchange between Prime and Creo. These are the screens. And now I start, not only me. So normally we start the calculation in Mathcad with our input data. In this case, it's a very basic beam, meaning that it has a rectangular section and a given length. In this case, the dimensions of the section are imported in Mathcad Prime, and that process I will show at the end of this short tour through Mathcad. So these dimensions, they come from the model in Creo Parametric. A big advantage of Mathcad as a concept, in contradiction with, for example, a tool like Microsoft Excel, is that it works with units, meaning that I can apply units to values. And this is what I do in this line, you see? So I can apply no matter what unit to my values. I can annotate everything I do with text. I can add hyperlinks to show my sources of information. And also here, because this is a design document, so we are in the process of making a distinction what kind of material will we use. I use the so-called combo box, meaning that I have the density, the young modules, and the yield strength of a given material. And a combo box allows me to make a distinction between these materials. And as a result, I can make a choice while I'm in the process of designing. I can see what difference does it make when I switch from steel to titanium, for example. So this is a very useful feature of Mathcad Prime. It's the so-called combo box. Then, of course, also very important. So I talked about the beam. So that means I have to define several nodes alongside the beam. In order to do that, I use the table functionality of Mathcad Prime. This is what we see here. And in fact, it's a matrix. It's a matrix in which I can apply units in the header, meaning that I hope this is clear. So this is the coordinate alongside the beam. So it's just the distance along the beam. And that is the vertical deflection I will apply. So by doing so, it's very convenient. I can, if I press Shift Enter, I can add an additional node if I find that useful. So because also in this design, it was the intention to add, to make a distinction, how many nodes will we use, what is the interdistance. So this is the intention of this worksheet. So I can do it very easy. I hope this is clear. Then I will go quite far because this is not a mathematical lesson, but this is the actual calculation. And in order to do that calculation, this type of calculation is best performed without units. It has some reasons. This is a little bit too technical, but for clarity, I decided to make this calculation without units. In order to do that, I need to define a custom function, and this is my function. And by doing so, I can remove the units from my values. So you see, there's no units in my value, and this will have some significant advantages in the next pages. So, okay, these are my calculation parameters. And you see, one of the advantages of Mathcad Prime is that I can mix text fields, math fields, and pictures in order to make a presentation. A presentation for technical people, for decision makers, in which I can show what I am, what is my design intent. And this is a very big advantage of Mathcad comparing to, for example, Python and other programs. These are programming languages. Mathcad is a what you see is what you get interface. So it's a very convenient interface. Here you see the definition of the singularity function. So it's made with the program function of Mathcad. There are several ways of notation. So this or this is exactly the same. I do it in this way because I thought this is maybe somewhat more clear. So this is the programming interface of Mathcad Prime. This is quite technical, so don't worry. This is I won't go too much into detail. But what is important in this slide, I derive my formulas, and this is the result. So I can mark it in yellow. So I have a system of equations. And in this particular case, I have 7 equations and I have 7 unknowns. So I want to know what are the unknowns, what are the reaction forces. So I need to solve the system of equations. And I can rewrite the system of equations as a multiplication of matrices and vectors. In Mathcad Prime, I can solve this system marked in yellow in 2 ways. I can do that with the linear solve command, and I can do it with its solve block. In this case, I will start with the linear solve, and the advantage of that is that I can program my matrices, and as a result, it means when I increase the number of nodes, the vectors will be modified accordingly. I will show that. So if I ask for this matrix, it will be populated automatically depending on my input, meaning that if I have 5 nodes or 10 nodes, it doesn't matter. The matrix will be calculated automatically. And this is what we see here. This is just a symbolic notation in order to help me to make this program. And after that, I can do it in an automatic fashion. The same for the other vector, like this. So I hope this is somewhat clear. And after that, I can solve for my unknowns. And this is what I want to know. These are my reaction forces in Newton. So only the first 5 entries are forces. These are integration constants. So just to mention a second solution, because I don't want to go too much in detail, is the common solve block. So a solve block is a preformed, let's say, entity in which I can ask the program to solve my system of equations. And basically, I have to provide some guess values to the program. I have to provide my equations. And after that, I ask the system, please solve me this system. And as you will see, the result is exactly the same as I do here. The disadvantage in this particular case is this is not modified automatically, meaning if I add a node, I have to modify my solve block manually. So for that reason, I chose to program it in this case, but that's maybe too much in detail. Long story short, after I calculated my forces, I can plot my results. And this is what we see here. And just for the presentation, for the sake of the presentation, I do it in 2 ways. This is the so-called chart component of Mathcad Prime. And the chart component that gives me the opportunity to annotate my plots in very high detail. So I can add annotations to the axis, I can add legends, I can modify any common entity of my plot. So this is what we call the chart component in Mathcad Prime. The other plots are quite standard plots. So here you see the deflection of my beam, and I indicated the nodes with the red dots. So this is the result of my calculation. And then I'm satisfied with my calculation because you will see these are markers. So I stay within the maximum allowable stress of my design. So I'm satisfied with my calculation. And after that, I want to communicate my results with Creo Parametric. So how can we do that? Well, in the ribbon interface of Creo Parametric, the system allows me, I will give a short demo. I will do it like this. The system allows me to define some. No, I will show what I have. It's more easy, I think. meaning that in this particular case, so as I have explained, I have some inputs and I have some outputs. And I can, with the assign input and assign output, I can define these particular fields in my calculation. And I also can give a certain alias, meaning that that is the name which will be communicated with Creo Parametric. If I do that, I can ask my sheet, to push it to Creo Parametric. But maybe in order to show that, I go first to Creo Parametric. So this is Creo. And under the Applications tab, we have PTC Mathcad. I did it already. That's the reason it's grayed out. I embedded my worksheet in Creo. And as a result, we see this icon, meaning that it's integrated in this part. And because it's integrated, I can push whatever I want to Mathcad, to Creo. And I can do it with this button. It's under Save and Push. So now Mathcad tells me Save and Push was completed successfully. If I now go back to Creo, I can ask Creo, please show me. So under parameters, I have a field embedded Mathcad. And these are my parameters I just pushed. So what is the advantage? After I bring them in the software, I can add relations using these parameters. In this particular case, it's quite basic. I told Creo Parametric to export the section of my beam to Mathcad with a simple relation. And I did the same with the position of the nodes. I will show what that means. If I, for example, if I modify the length, the width of my beam to 60, now I say Control G. Then I go back to Mathcad, and then I will go to the concerned field on the first page, Control Home. And here you see the field. If I now say update inputs, we will see that this input field is updated immediately. So this is an advantage. So I can switch back and forth between Creo Parametric and Mathcad Prime. And the same applies for the position of the nodes. So I will give a short demo of that because it's nice to show. So in this case, this is the position of my first node. So suppose in my calculation, for some reason, I want to change this position from 45 to 4, for example. Then I can say, listen, push that to Creo. So save and push was completed successfully. I go back. Now the Creo says me, hey, you changed something in your Mathcad sheet. So I press Control G, and now you see the position is modified immediately. So this has some advantages. So I can make my calculation in Mathcad, and I can communicate it to Creo Parametric. And by doing so, I can stay within the same environment. So I have my embedded worksheet, I have my model, and this is something, in my opinion, that could be very convenient, because from a certain level of mathematics, it's not very convenient to do it in the relation fields of Creo Parametric. It's not very suited for, let's say, more advanced calculations. So this is a very big advantage of the symbiosis between Mathcad Prime and Creo Parametric.